We've been talking about ions, how to name them, how to write the how to write the formulas for them. We talked about monoatomic ions, ions that only have one atom in them. Now we're going to talk about polyatomic, poly being a prefix that means many, many atom ions. Polyatomic ions usually contain one or more elements combined with oxygen, and they are called oxyanions. There are a few polyatomic ions that are not oxyanions. Most of these oxyanions end with the suffix -ate. The monoatomic anions, like from chlorine and bromine, etc., we changed the ending to -ide, I-D-E. These guys end with A-T-E, or some with I-T-E. Cyanide and hydroxide ion are probably the most important polyatomic ions that also have that suffix -ide. And that can be a little confusing. I'm sorry about that. Ammonium ion is the only polyatomic cation that you have to know. The rest of them are all anions. And ammonium, let's get my pen up here, is NH4+. So that's the only polyatomic cation we're going to run into in this class. So here's a list of common polyatomic ions from your textbook. See what the title says? Memorize these ions. You need to memorize them. It's just one of those things. You've all memorized the alphabet, right? Does it take some work to memorize these ions? It does. Did you have a question?
Are these handout as well?
They should be on that green chart, yes. There's probably more on the green chart. So these are the most commonly encountered ions. You're taking this class so that you can take Chem 1A. You have to know these ions for Chem 1A. There's just no way around it. Okay. There are some patterns in here. If we look at like ClO3 is chlorate ion, the beginning of this name is related to the element that's with oxygen. A lot of them are like that. Here's chromate, it's got chromium in it. Nitrate has nitrogen in it. And we need to know their names. The spelling matters because look how close these are, nitrate and nitrite. Those are two very different ions. And when we write formulas, we have to be very precise as well. Nitrate is NO3 with a -1 charge. Nitrite is NO2 with a -1 charge. Okay, so this is a good place to use flashcards. Okay, pack of index cards, write the name on one side, write the formula on the other, and just carry them with you. And when you're waiting for class to start, just, look through them until you've got them down. So one of my tricks for some of these ions are to memorize what I call the ates. So let's go back to this for just a minute and find the ates. So there's carbonate, chlorate, chromate, nitrate, and sulfate. I don't think I missed any. Acetate is an 8 too, but it's not in the pattern that I'm going to show you. Chlorate, chromate, nitrate, sulfate. Oh, I missed phosphate. There's somebody missing. Phosphate. Those guys are important. And then there's a pattern. So I'm going to show you with the chlorate family. Here's chlorate in the middle, ClO3-. You just flat out memorize that one. But then there are prefixes and suffix changes that are related to the number of oxygens. Do you see the pattern here? 1 oxygen, 2 oxygens, 3 oxygens, 4 oxygens. The charge on the ion is exactly the same. They're all -1. They all have 1 chlorine atom in them. The only difference between these 4 ions is the number of oxygens. Okay? So chlorate, you memorize it. When we say that a child is hyperactive, are they more active or less active than a normal child? More. Hyper means more or above. So we don't use all of that word, but the per means more active, like hyper is more active. So perchlorate is 1 more oxygen than chlorate. Okay, 1 more is, you put a per in front. Chlorite, this is like the light version of chlorate, because Bud Light has 1/3 fewer calories than regular Bud, right? It's the light version. Chlorite is the light version of chlorate. It's got 1 less oxygen. So you memorize chlorate, and then if you need chlorite, you just subtract an oxygen. And then we've got hypo chloride. Hypo is a prefix that means below. I know some people are creeped out by it, but where does a hypodermic needle go? Below your skin. Your skin is your dermis. Hypodermic means below the skin. So hypo is a prefix that means less than or below. So hypochlorite is 1 less oxygen than chloride. You see the pattern there? And this pattern works with the other 8s. Now, using this pattern, you could make names and formulas for ions that don't actually exist, but that's really not going to be a problem in a class like this, because we're only going to ask you to name things that actually exist. And if you know the pattern, you can do them. So we could do things like bromate. Now, bromate was not on the table on the previous slide. But what group is in the periodic table is bromine? It's in group 7A, right? It's right below chlorine. Chlorine and bromine are like sisters. They have a lot of things in common. And their relationships with oxygen are the same. So if chlorate is ClO3-, what do you think bromate is? It's BrO3-. Same number of oxygen, same charge. Just swap out the bromine and the chlorine. I don't have a group of daughters. I refer to the nonmetals as feminine usually. But I have 5 sons, and they have some striking resemblances to each other. And so right now my 3rd son is going to high school, and people are calling him one of his older brother's names because they get him confused, because he looks like his brother. Is he his brother? No, he's a separate person. He has his own characteristics, but he has a lot of things in common with his older brothers. They all play football, they all play guitar, they're about the same size, about the same color. They look very similar to each other. Bromine and chlorine are sisters, and they behave that way. And so per bromate, all you have to do is put in a Br and change chlor to brom. That doesn't show up very well at all. Let's see if I can fix that. So if we put Br in here, that's per bromate. They're kind of interchangeable. You swap the element symbol in, and you swap the stem of the element's name in. So what would be the formula for hypobromite? It would be BrO-. This is hypochlorite with 1 Cl, 1 oxygen, and a -1 charge. Hypobromite follows exactly the same pattern. We're just going to put bromine in there instead of chlorine. It works for iodine as well. Okay? So if you memorize chlorate the name in the formula, and you can remember this pattern of prefixes and suffixes, you can name and write formulas for 12 ions. That's a pretty big bang for your buck, right? For a small amount of studying, you can name and write formulas for 12 different polyatomic ions. Let's do another one. So nitrate is NO3 minus. That's one you're supposed to memorize. What's the formula for nitrite? NO2 minus. The ite tells us just take one oxygen away. It's the light version. It's got less oxygen than the regular one. Okay? So any questions about those? It takes some practice. It takes some memorizing. Yeah? You need to memorize the entire slide. All of those. Like bromate and iodate could show up. But you're also supposed to know this pattern.
Plus the last slide.
Yeah.
That's all.
Yeah. There are a couple of ones on here that are a little bit weird. Acetate ion looks a little strange. This is actually an organic anion, but we run into it a lot. C2H3O2 with a minus charge. That's not going to, you're never going to see anything with that ite, hypo-ite, per-ate pattern thing with that guy. Dichromate is weird. Dichromate has a prefix di on it, which we rarely see in polyatomic ions, and that suggests that it's double of the chromate ion. Well, it's got 2 chromiums, but it doesn't quite have 2 oxygens, 2 times the number of oxygens. It's got 7, so that one's a little funny. And then we've got this guy, hydrogen carbonate, hydrogen sulfate. Oh, and they're not making you do a hydrogen phosphate, so that's okay. So hydrogen carbonate. What kind of an ion does hydrogen form? It can actually form 2 different ions. It can form an H plus ion or an H minus ion. The hydride ion, this guy down here, he's much less common. But this guy is very common. If I put a hydrogen ion with a carbonate ion, I get hydrogen carbonate. So I've got an H in here, and the sign, the charge has changed. It was 2 minus, but I've got 2 minus, and I'm adding a positive charge, and so this has a -1 charge, hydrogen carbonate. And then hydrogen sulfate follows the same pattern. Here's sulfate, SO4, 2 minus. So I'm putting together H plus and SO4, 2 minus. And when I combine them together, I get HSO4. I add those charges together, and it's -1. So these are the 2 most common ones you see where the ion has 2 names. Usually ions just have a single name, just like people use a first name. That's usually just 1 word. But some people have 2 words in their first name. Any other questions?
Why is hydrogen 4 when it's acetate?
That's a good question. We're going to talk about acids. Acidic hydrogens always go first, and these hydrogens are acidic. The hydrogens in acetate are not acidic. Acetate shows up a lot in inorganic chemistry, although it is actually technically an organic compound, and so it follows some slightly different rules. And so for acetate, the best I can really do is say just because. The fact is, for a beginning chemistry class, I'm kind of forced to lie to you sometimes. Just like with, a young child asking about things that their brain is not ready to understand yet because they need to know some other things first. You kind of lie to them sometimes, right? Or you skim over, you leave facts out. It's not malicious lying. I'm not trying to deceive you. But if I launched into the whole explanation, it could take a few hours, right? So do you need to know the full explanation? No, not to be successful in this class or in Chem 1A. And if someone's really, really curious about anything, you can come to my office hours and I'll be happy to talk to you for a couple hours. Any other questions? It's a good one. So provide a systematic name for each of the following polyatomic oxyanions. When you're first starting out, the way you're going to do this is you're going to go look at the table. And then later, you should be able to do these from memory. So NO3 minus, any guesses? Nitrate ion. How about OH minus? Hydroxide ion. What about this guy? That's acetate. And this last guy? Hydrogen sulfate. Just a reminder that all of these slides are posted on OneDrive, and so if you want to print all of them or selected ones, you can do it that way. Provide formulas. We have to go both ways. Given a name, write the formula. Given a formula, write the name. Dichromate. Cr, because it's got chromium in it. Di is the Cr2, and that's O7, 2 minus. Bromate ion. And that one's not in the table, but it follows the same pattern as chlorine. BrO3 minus. Phosphate ion. PO4 3 minus. There is some educated guessing that you can do on these. Phosphate, the 8 tells you this is an oxyanion, so it's got oxygen, and the phosp says it's got phosphorus in it. So it's going to be P and O in some combination with some sort of a negative charge. That can, on a multiple choice exam, that can knock out a couple of wrong answers and increase your guessing chances. And that is not, that's not cheating. That's just hedging your bets. It's okay to do. This guy, hydrogen carbonate. This is a hydrogen ion with a carbonate ion. So it's HCO3, 1 minus. Carbonate is 2 minus, but when we add that hydrogen ion, we get a -1 charge. Any questions?